Okay, so taking what we know from solving equations, we're going to apply that to solving inequalities. So let's briefly go over how to complete a number line and also how to interpret a number line. So if I start with number 1 on today's notes, okay, this says x is less than 3. The inequality tells you if it's an open or closed circle. So if it's less than or greater than, it's an open circle. If it's less than or equal to or greater than or equal to, then it's a closed circle by coloring it in. So this one's going to be an open circle on the 3. And I'm looking for values where x is less than 3. And the only direction where values are less than 3 is to the left, so we're going to shade that way. Number 2 is an open circle as well on the -1. I'm looking for values where x is greater than -1, and the only direction where values are greater than -1 is to the right, so I'm going to shade to the right. Number 3 is a greater than or equal to, so I'm going to do a closed circle on 4. And I'm looking for values where x is greater than or equal to 4, and the only side where values are greater than 4 is to the right. Number 4 is a closed circle as well on -6. I'm looking for values where x is less than -6, and be careful when it comes to negatives. The higher the negatives, the less it is. So we're going to shade to the left. So be careful when it comes to negatives. When I interpret a graph, it's the same idea. So x, and I know it's an open circle, so it's going to be less than or greater than. And since it's less than 13, these are values less than 13, x is less than 13. Number 6, I'm looking for, it's a closed circle, so it's going to be less than or equal to or greater than or equal to 7. And since these are values that are greater than 7, greater than or equal to. Number 7 is a closed circle as well, and it's on the -18. These are values that are less than -18, so it's less than or equal to because of the closed circle. And number 8, it is an open circle on the 10. And these are values that are greater than 10, so greater than, no equal to, because it's an open circle. So when you're solving inequalities, you have to follow another rule. It's not just as simple as solving equations. You have to remember that you must flip the inequality symbol when you multiply or divide by a negative number. Only when you multiply or divide by a negative number. But for solving equations, we're going to follow SADMEP, as we've done so many times before as we're solving this. So let's take it one step at a time. So number 9, the inverse of adding 2 is to subtract 2 first. So 3x, because the 2's cancel. -4 minus 2 is -6. It's no longer an equal sign, it's a less than sign, so make sure you bring that down also. Then I'm going to divide by 3. Notice I divided by a positive. That means nothing happens to the symbol. It stays x is less than -6 divided by 3 is -2. It's an open circle, and I'm just going to fill this in real quick on -2. Values where x is less than -2 would be to the left because -3 and -4 are less than -2. Number 10, I'm going, the inverse of adding 2 is to subtract 2 to both sides. So x over 6, the 2's cancel, is greater than -1 minus 2 is -3. The inverse of division is to multiply by 6 to both sides. I did not multiply by a negative, so it stays greater than. -3 times 6 is -18. It is an open circle on -18, and I'm looking for values that x is greater than -18, which would be to the right. So -17, -16, -15, all of those values all the way to the positives. Okay, as we continue this, so we're just going to keep the same thoughts in mind. The inverse of adding 8 is to subtract 8 to both sides. I have -7x less than or equal to, the 8's cancel. 1 minus 8 is -7. Here, I'm going to divide by -7. Since I divided by that -7, it flips this inequality to greater than or equal to. -7 divided by -7 is +1. Number 12, the inverse of subtracting 5 is to add 5 to both sides. X over negative 8 is less than negative 2 plus 5 is 3. The inverse of dividing by negative 8 is to multiply by negative 8. The negative 8's cancel. I have x. Since I multiplied by negative, I got to flip this sign, so it's not less than anymore, it's greater than. 3 times negative 8 is negative 24. I haven't been doing the number lines, I apologize. It is an open circle, and I'm looking for values that are greater than negative 24, which would be to the right. Number 13, the inverse or the opposite of positive 3 is to subtract 3. So the 3's cancel. I have x over 7 is greater than or equal to 1 minus 3, which is negative 2. The inverse of division is to multiply by 7. I did not multiply by a negative. I multiplied by a positive. So this stays greater than or equal to. Negative 2 times 7 is negative 14. It is a closed circle on negative 14, and I'm looking for values where x is greater than negative 14, which would be to the right. Number 14. The inverse of subtracting 5 is to add 5 to both sides. I have negative 2x, 5's cancels, less than or equal to 19 plus 5 is 24. Divide by negative 2, which is the inverse of multiplication. Since I did divide by a negative, I'm going to flip this inequality from less than or equal to greater than or equal to. 24 divided by negative 2 is negative 12. It is a closed circle on negative 12. I'm looking for values that are greater than negative 12, which would be to the right. Number 15, the inverse of or opposite of positive 3 is to subtract 3. So I have negative 4x less than 31 minus 3 is 28. I'm going to divide by negative 4. By dividing by that negative 4, this flips the inequality from less than to greater than. 28 divided by negative 4 is negative 7. It is an open circle on negative 7, and I'm looking for values where x is greater than negative 7, so that would be to the right. Number 16, the inverse of adding 5 is to subtract 5 to both sides. 3/4 x is greater than 11 minus 5 is 6. Normally I would divide by this 3/4, but the dividing by a fraction is the same thing as multiplying by the reciprocal, so I'm going to multiply by 4/3. So x is greater than, because it didn't multiply by negative, so it stays greater than. 6 times 4/3 is 8. It is an open circle on 8, and I'm looking for values that are greater than 8, so it would be shaded to the right. Number 17, the inverse of subtracting 1 is to add 1 to both sides. I have negative 5, 6, x is greater than or equal to 15, because 14 plus 1 is 15. I would divide by negative 5, 6, but dividing by a fraction is the same thing as multiplying by the reciprocal, negative 6/5 to both sides. Since I did multiply by a negative, that flips the sign from greater than or equal to less than or equal to. 15 times negative 6 over 5 is negative 18. It is a closed circle on negative 18. And I'm looking for values where x is less than negative 18, so it's going to shade to the left. Number 18, the inverse of subtracting 2 is to add 2 to both sides. I have 5x is less than or equal to negative 7 plus 2 is negative 5. I divide by 5. I did not divide by a negative, so I'm going to leave less than or equal to less than or equal to. Negative 5 divided by 5 is negative 1. It is a closed circle on negative 1, and I'm looking for values where x is less than negative 1, so that would be to the left. The opposite of positive 6 is to subtract 6. I have negative x is less than or equal to 14 minus 6 is 8. There is a negative 1 there, not a 0, so the inverse of multiplying by negative 1 is to divide by negative 1. Dividing by that negative flips this inequality to greater than or equal to. 8 divided by negative 1 is negative 8. It is a closed circle on negative 8, and values where x is greater than negative 8 is to the right. Number 20, last one. The inverse of adding 4 is to subtract 4 to both sides. I have negative 1/3 x is greater than 11 minus 4, which is 7. Then to divide by a negative 1/3 is the same thing as multiplying by the reciprocal, so multiplying by negative 3 over 1. So the x, since I multiplied by a negative, this flips the inequality to less than. 7 times negative 3 over 1 is negative 21. It is an open circle on 21, and values where x is less than negative 21 would be to the left.